In this video, we are going to talk about stateless versus stateful operations in Spark Streaming. Now, in general, the operators in structured streaming can be broken down into two categories. So, first one is stateless and second one is stateful. Now, what exactly is meant by that? So, I have listed down some differences between the stateless operations and the stateful operations here. We will understand them one by one. So, the first one says that each batch of data is independent and there is no any reference to the previous batches. What does batch mean? If you remember, Spark is a micro batch system. So whatever data it is reading from the continuous source, it is in the batches. So whenever it is reading, let's say the first batch, so that batch is independent of the next batch. So there is no relationship between that. That is for the stateless operations. For the stateful operations, let's say there are batches like batch B1 and B2. Now, there may be some correlation between these two batches. That means it will maintain the state across multiple batches of data. We are going to see an example of that in a few moments. The second one says that the output of a batch is only based on the data in that batch. So, if you have batch B1 and a batch B2, let's say you are doing some transformations on B1. So whatever output that you are generating for stateless operations, the output will be only based on the batch B1. For the output of the batch B2, it will be solely based on the batch B2. So the output of B1, there is no relation with the B2. Similarly, the output B2, there is no relationship with the batch B1. In stateful operations, the output of a batch depends not only the data in that batch but also on the state of the system accumulated from previous batches. What does that mean? So if you have B1, B2 and B3, the three batches of data in stateful operations, the output, whatever transformations you are doing for each batch, let's say this is BO1, this is BO2 and this is BO3. O means output. Now this BO2 can be dependent on the B1 also, B1 and B2 both. So this B3 can be dependent on the B1, B2, B3, all of that. So in stateful operations, the output of a batch can depend on the previous batches as well. Now this is very intuitive because since it only depends on that particular batch only for the stateless operations, it will be faster and it will consume less memory because we are not maintaining any state across batches, so it will consume less memory. Whereas for stateful operations, it is slower and it consumes more memory because we are maintaining the state across batches. In stateless, we are not maintaining the state across batches. The fourth one says it is easy to scale horizontally since there is no need to keep track of the state across multiple nodes. Whereas in the stateful operations, it is a little harder to scale horizontally. Why? Because let's say you have different nodes. Let's say you have n nodes in a cluster, and whatever your states are, those will be stored across the nodes. Some state will be stored here, some here, some here, some here, and some here. Alright. So for a stateless operations, let's say you want to introduce more nodes. You can introduce one more computer since it doesn't maintain any kind of state and it doesn't depend on the previous batch of data. So whatever state is coming in, it doesn't care. This particular node can be used to perform simple operations like filter and map, which are stateless operations. So there is no need to maintain the state. But for stateful operations, already let's say these systems are containing these states. So you want to introduce a new node. The state of the intermediate state needs to be handled accordingly because this node is a new node and it will also need to understand how the states will be stored in this new node. Now some of the examples of the stateless operations are filtering and mapping. For stateful operations, if you see, windowed aggregation is kind of a stateful operation. Let's understand this with an example. So let's say we have some micro batches here in Spark. I have named them micro batch 1, 2, 3 and 4, and there is some data that is coming in for each micro batch. So let's say we have some values coming in, let's say comma separated words or letters you can say. So A B C D is our first micro batch, then B C D is our second micro batch, and so on. Now for stateless operations, if you remember, map and filter are kind of stateless operations. Why? Because let's say for this micro batch, I want to filter, I want to find only those records which are matching with the letter B. This is the filter operation. So for A B C D, what will be the output? Let's say I want to match only B. So there is one record, so B will come. So the output of this particular batch only depends on this batch. Understood? This is what we meant earlier. Similarly, let's take an example of micro batch 2. We want to do another filter operation on batch B2, and we want to say filter only those records where the letter is not equal to D. So what will be the output? The output will be B, C and E. Again, if you see, the output of the batch B2 is only dependent on the batch B2. It has no correlation or no relationship with the previous batch or the next batches, obviously. Now let's go to stateful operations. Now, as I mentioned, stateful operations aggregations here is a stateful operation. How? Let's see. Let's say we want to maintain a count, letter count. So for each of the micro batch that is coming in, we want to maintain the count of the letters. Let's say how many times the letter is coming. For example, A is 1, B is 1, C is 1 and D is 1. So for the first micro batch, this will be the output, right? Now for second micro batch, what will happen? So since this is stateful operation, so it will remember the previous state of the entities. So in batch B1, this was our count. For batch B2, since it is a stateful operation, it will see what are the letters here. So B, C, D, E. There is a B already there. So B is there in the batch B2 also and batch B1 also. Since it is maintaining the state in memory, so the count will be incremented. And then C is 1, D is 1, E is 1. So for batch B3, now G is 1, H is 1, I is 1, J is 1. So as you see, there is no letter that is getting repeated in batch B3. So all of the counts are 1. Similarly in batch B4, M1, N1, O1, P1. So this is the output of the individual batches. Now if you see here, the output of batch B2 depends on the batch B1, is related to the batch B1 because there is an element here which matches also in the batch B2. So that's why the count is incremented here. So if any of the letters would have come here, the count would have been incremented. So that is what we meant when we said that the output of batch depends not only the data in that batch but also on the state of the system accumulated from previous batches. This was an example of the stateless versus stateful operations. Now let us understand what are the state store providers in Spark Streaming. So in Spark Streaming, there is a default state store provider which is HDFS state store provider. So I mentioned here, this is the default, and it uses memory map and also the files in HDFS. So whatever key values it is storing in the HDFS file system. The default HDFS state store has some memory issues respect to garbage collection. So when it comes to handle the millions of keys, then the HDFS state store provider is having memory issues. The second one is RocksDB state store provider. This was developed by Facebook and it is a persistent KV store. The important point to note here is the state is not kept in JVM. So it is kept in the native memory and the local disk. So that is why it does not suffer with the GC problem. How can you enable this RocksDB state store provider? You'll have to provide a configuration which is spark.sql.streaming.statestore.provider class equals this class. Now let us understand what is managed and what is arbitrary stateful operations. So when we say managed, so the managed stateful operations are managed by the Spark itself. The very simple example is group by aggregates. So when you say group by and when you say count, so that is managed by the Spark itself. That is called managed stateful operations. But what if you want to manually manage the state? So you want to decide when you want to time out a particular state of an entity and not let Spark decide when to time out. A lot of the use cases are already handled by the managed stateful operations. But let's say you have some kind of use cases like the sessionization, where you want to manage the user session individually. For that, you will need to do arbitrary stateful operations. So arbitrary means you will manually handle the state yourself. What exactly is meant by sessionization here is, let's say some users are visiting your website. So user 1, user 2, user 3, user 4, and you have a timeout of, let's say, 30 minutes of inactivity. So you want to understand what the users are doing on the website. What are they clicking, whether they are purchasing something or not, like add to cart, whether they are doing the payment or not. Alright, so there are different things that you want to track for each user, and you also want to time out for the 30 minutes of inactivity. So you want to do sessionization. So for that, since you need to time out them in 30 minutes, so you'll have to manually handle the state for each of the users. So there is a provision how you can do that. So there are two functions that Spark Streaming provide. The first one is map groups with state. The second one is flat map groups with state. These are the two functions that you can implement for handling the arbitrary stateful operations. There are three things that we understood. So what is stateless versus stateful operations? So what are state store providers? For example, HDFS and RocksDB state store providers. Then we understood what are managed and what are arbitrary stateful operations. Now we are going to see an example of the stateless versus stateful operations. In this example, we are going to understand the stateful versus stateless operations. We have the sample data here, and this sample data is a clickstream data. The data contains the ID, the event time, the clicked resource, the device type, and the OS version. Let's say this is stream of data that will be coming in from the Kafka. Our Spark streaming applications will be reading from this Kafka topic, and we will be manipulating this data. Now this ID is the user ID. The event time is when the event was triggered. The clicked resource is what the user clicked. So item 1, item 2, checkout, add to cart, etc. Device type is what kind of phone the user is using, whether it is an iPhone or an Android. I have listed only two values here. Then what is the OS version of the device? Now let's understand this example code. As per the data, I have created a case class which is called device info, and I have given the schema, the ID, event time, clicked resource, device type, and OS version. I have created a Spark session. These are some of the properties for the Kafka. We have given a JSON format schema as per this data. Again, this Spark implicits is for converting data frame to dataset implicitly. We are creating a data frame by reading the Kafka topic. So this is a data frame. We are creating a dataset out of it. Whatever value we are reading from the Kafka, we are casting that as string. And finally, we are using the from JSON because this is a JSON data. So we are using the from JSON function. We are deserializing it, and we are providing the schema that we defined here. We are giving the case class name to create a dataset. Now we are going to see two different operations. The first one will be stateful operation, and the second one will be stateless operation. For the stateful operation, what we are going to do is, so the dataset that we have created here, we are going to manipulate it and write to the console output. We are creating a new column called event time, and the event time was of string type. We are converting it to timestamp type. The watermark is based on the event time which what we are giving, and we are saying okay, the data which is at max 15 minutes late can be aggregated, otherwise don't aggregate it. Then we are grouping by the event time. and the ID. Finally, we are going to write this output to console sync, and we are saying do not truncate the output, and trigger dot processing time is 3 seconds. So after processing the current batch, Spark will wait for 3 seconds to trigger the next batch. Output mode is update, which means that Spark will be able to update the state across batches. We have given checkpoint location. This start doesn't mean that our query is yet started. Let's see the stateless operation here. Now, stateful operation, we are doing a group by count and an update, obviously, and across the batches, it will update the count. The stateless operation here is a filter operation. So, whatever dataset we created here, we are saying, okay, if the device type is iPhone, then what you need to do is you convert it to a JSON format and write it to a Kafka topic. And the Kafka topic name is desk topic, which means the desk topic is iPhone devices. So whatever data that is coming in after filtering, it will be written to the destination topic. So for each of the micro batch that is coming in, the output of that micro batch will depend on that batch only. For whatever records came after filtering, those records will be directly written to Kafka. There is no relation to the previous batches. That is why this is called stateless operation. Here we are using append, which means that whatever data is coming in after filtering will be continuously getting appended to the Kafka topic. So there is no updates, there is no relation to the previous batches. This is stateless operation. Now imagine this is stateful operation, so obviously it will take more memory because it will have to maintain state in memory. This stateless operation does not require any kind of state management, and that is why it will take less memory. Finally, we are saying that start both the streams. Whatever streams are there, just start them. Now we are going to run this example and see its behavior. So I have started the zookeeper and I have also started the broker. The Kafka console producer is ready and the iPhone devices consumer is also ready. Now our application is running. Let's go ahead and provide some data to the console producer. So let's say we are providing the first 3 records here. Let's put it here and let's go and see the consumer. Since we have filtered the records based on the device type iPhone, so this topic will only contain the data which has device type as iPhone. Now let's go ahead and see the console, because this is a stateless operation and this is a stateful operation. So stateful operation will maintain the state in memory. The unique count of the window and the ID will be presented here. So for this window user 5 is 1, for this window user 3 is 1, for this window user 2 is 1. Now we will try to find out any other event which is falling between this time window for user 5, user 3 or user 2, and we will see whether this count is getting incremented or not. I have highlighted one record which is for user 5. The event time is 12:27:50 am, which is falling between 12:15 am to 12:30 am. Let's go ahead and put this record. See the iPhone devices. It is not, it is Android, so it will not come here. But let's go ahead and see the console. This is update mode. If you see the previous output, the user 5 is from 12:15 to 12:30. The count is 1. In the next micro batch, there was just one record and it matched the user 5 and the window also. So that is why you see for this window user 5 the count is incremented. For output mode, it will not output this value and this value. It will only output the changed since the last trigger. So this is the value that got changed. So that is why the update output mode will only display the value which was changed since the last trigger, which was updated since the last trigger. If you want to understand more about the output modes, I have created videos where I have explained the complete output mode, append output mode, and the update output mode in a very detailed manner. So I will suggest please go and have a look at that. So as you can see, the stateful operations are maintaining the state across batches, whereas the stateless operation does not maintain any kind of state. So I hope this concept is clear with you. If not, leave me a comment and I will try my best to explain it to you. So that is it for this video, guys. Thank you for watching. Happy learning.